Okay, next we're going to look at a key concept for the expected value of a discrete random variable. The expected value of a discrete random variable is the weighted average of the values of the variable. It's calculated by finding the sum of the products of every possible value of x and its associated probability of x. So the expected value is essentially the sum of each of the individual x values times their probability. So for example 4, we're going to calculate expected value. This scenario is a tetrahedral die, meaning tetra meaning 4, has 4 sides numbered 1, 2, 3, and 4. Find the expected value of one roll of this die. So if you think about something that has 4 possible outcomes, what's the probability of each of the outcomes? Well, the probability should be 1/4. So 1/4 of the time we should be able to roll a 1. 1/4 of the time we should be rolling 2 or 3 or 4. So the first outcome is 1, and the probability of that is 1/4, 0.25. The second is 2, and then times 1/4, 0.25. 3 times 0.25, 4 times 0.25. You sum up all of those, and you get 2.5. So the expected value essentially is kind of like the average. The average value of what you would roll is like 2.5. Here's a check your progress problem on this. Go ahead and find the expected value of one ticket. Go ahead and pause the video. When you have your answer, go on to the next screen. Okay, our answer this time is $1.88 for the expected value. What you would need to do is take 10, take the total number of tickets, which is 2,000, take the prize, x times the probability, that would be 100 out of 2,000, etc., etc., etc. Work through and find the expected value. Next, we have a key concept on the standard deviation, how you find standard deviation. So, standard deviation is based off of the variance formula, and the variance is essentially the square of the standard deviation. The standard deviation is this symbol, sigma. It's a lowercase sigma. This is a capital sigma right here. This is a lowercase sigma. So first you find the variance, and then you take the square root of it to get the standard deviation. So the variance formula is the sum of each of the x values minus the expected x value. You square it, you multiply it by the probability, and then you sum up each of them. Once you have that answer, you take the square root. That's how you get standard deviation. So for example 5, we're going to be finding the standard deviation on a raffle. It says at a raffle, 400 tickets are sold for $1 each. 1 ticket wins $100, 5 tickets win $10, and 10 tickets win $5. Calculate the expected value and the standard deviation of the distribution of winnings for a $1 ticket. So the first thing you're going to want to do is to make a frequency table that lists the prize or the x, the different outcomes, the number of tickets, and the probability of each of those things happening. So, of 400 tickets, 16 win a prize. So we can see that here. 1 ticket wins 100, 5 tickets win 10, 10 tickets win 5. So we have 1 plus 5 plus 10. There's 16 tickets that win a prize, which means that there's 384 tickets that don't win a prize. So if I buy a ticket for $1 and I happen to be the person that wins the $100 ticket, then I've made $99 essentially, because I paid $1 and I won 100. So the prize of $99 can only happen one time. And 1 time divided by 400 is 0.0025, the total number of tickets. 5 tickets win $10, so 5 times there would be a prize of $9. You win 10, you paid 1, you win $9. So 5 divided by 400 is 0.0125. There's 10 tickets that win $5, but they paid $1, so their prize is actually $4. So if you take 10 and you divide by 400, you get 0.025. And then all the other tickets, which are 384 of them, you pay $1 and you don't win anything. So essentially your prize is that you lose $1. And if you take 384 and you divide by 400, you get 0.96. One thing before we move on is that if you take all these probabilities and you add all of them up, you will get 1, because all the probabilities need to sum up to the number 1. Okay, so now that we have our x values, we have the tickets, we have the probability, we're going to work through the formula to find the variance, and then take the square root of that, and that will find the standard deviation. So the expected value is the first outcome, which is 99, times the probability of it happening, plus the second outcome, winning $9, times its probability, times the third outcome, 4, times its probability, times the last outcome, times its probability. You add all that up, and you get negative 0.5, meaning that the average person who plays into this raffle will lose 50 cents. So our expected value is negative 50 cents. What you're going to do is work from a table. We have our x values, we have our probability of it happening, we have the x minus the expected value, and then squaring it, get these numbers. Then we take these numbers, we multiply them by the probability, and we get these numbers. Then we're going to add up these 4 numbers to get 27.63. That's the variance. Then we square root that, we get 5.26 as the standard deviation. So let's look at a real-world problem to check your progress. Same kind of scenario. You want to go through the same steps that we just did. You're going to need to find the expected value and the standard deviation, the distribution of winnings. This time for a $5 ticket. Selling 500. 1 of them wins 1,000. 2 of them win 500. 10 of them win 50. So pause the video. This is going to take you a little ways. Once you have your answer, come on back and we'll see the answer on the next screen. Okay, our answer this time is choice D. The expected value is $0, meaning that the average person wins nothing. The standard deviation is 55. That brings us to the end of Unit 5, Lesson 3 on probability distributions.